Okay. Hello, everyone. How are you this morning? You good? Yeah, great. Great. You enjoying the conference so far? Me too. Okay, thank you all for coming here. I'm going to talk to you about API, ABI versioning, and basically how to handle impacts in your code when you do a change, any kind of change. The question usually you should ask yourself when you change something, when you release a new commit is, what are the impacts? Am I going to break something for somebody if I push this change? And I really like to thank Titus who gave me a hell of an introduction yesterday, because he said that basically, you can tell. He said that basically the idea is that there are so many things that could go wrong that you can't predict, so many use cases you could not have foreseen. And he insisted on two parts, especially that Semver was clearly not the option, and that wanting to handle binary compatibility was just madness. Guess what I'm talking about today? Semver, binary compatibility. Great. All right. Joking aside, the meat of this talk is more about explaining to you what kind of impacts you should expect from the change in your code, because I think there is some place here to be able to tell what people can expect from something you will change in the code. So we'll study the impacts on the API if you choose to change something. We'll study the impacts on the ABI, so binary compatibility. And then we'll see how to try to put a category on them, like is it going to break or is it going to be fine? And of course, how to communicate with your developers to tell them that you changed something and that they should expect, what to expect exactly. For those who were not on my previous talk today, hello, my name is Mathieu, I'm from France, and I work at Murex. I work on internal frameworks, I work on some open source initiatives which are not published yet, unfortunately. And so, I have to ask myself a lot of questions about life cycles and how to maintain things in the long run. You can follow me or contact me at the social media of your choice. So let's talk a bit about the life cycle of a library. So let's say you want to publish something. You want to publish a library, you want to create something, you want to put it out to the world, some nice code you have. There are like a million questions you can ask yourself about what's going to be, what are going to be the impacts, what should I be afraid of. And since there are a million of them, I'll just try to answer the one I think are really pertinent in that case. The first one being, will all your users belong to the same repo? Because, of course, it's a different world if all the people that use your code are in the same Git repo, or if you are just one of the, I don't know, billions repo on GitHub, and that people will pull your code in their code base and use it. On the first side, if you break something, you will know immediately. You will probably not get past the pull request. It will be obvious. In the second case, not so much. So of course, in the first case, versioning is not mandatory. You will see immediately that you broke something. And then again, I think it's not enough to think that you don't have to worry before pushing. Because I think pull request is a bit too late to notice that you broke something for other people. And instead, I think we should be more proactive, more preemptive, trying to think about what will change, what will impact people if you push that modification. Second question will be, will you ever break backward compatibility ever in your library? That's not a common use case to not break at all, but I know that some of you might have some constraints or might have some will to say, I will never break backward compatibility ever. I will just, like, I don't know, provide a new namespace every time, but everything I put there, it will still work 10, 20, 30 years from now. Again, remember that even if you decommission something, if you say, okay, it's deprecated, and that 20 years later you remove it, technically you're breaking backward compatibility. So when I'm saying never break, it's really never. So, of course, if you do it even rarely, even once in 10 years, you have to have a way to distinguish between a breaking change and a non-breaking change. This one is quite important. Will your users ever have to hot swap your library in production? Again, I think there are multiple use cases here. On one side, we have the nice things Google showed us yesterday, the live at head ID, that basically you always recompile everything. Maybe you have, I don't know, some cloud application, or you use Docker, I don't know. But maybe not. Maybe you have a library that's installed on servers, that's installed on machines. It's really sitting at the bottom of the chain of the dependencies, and you cannot allow yourself to break binary compatibility. I mean, imagine that you're a maintainer of, I don't know, like OpenSSL or the C runtime. Can you just say people, well, sorry, I broke the ABI, I broke the API, just recompile everything that depends on it. I used to have Gentoo at home. If anybody has ever tried to recursively recompile all dependencies on libc, well, I know it's not feasible, it's not reasonable. So if that's your use case, you will have to worry about binary compatibility. You will have to worry about the ABI. Of course, if you're header-only library, and I know that it's quite trendy right now, you don't have that option. You're never going to be able to offer people a binary to hot swap because, well, by definition, you don't have any binary. So basically, it's important to know when you're going to change something. It's important to try to categorize, will it break or will it not break my user's workflow? If you want binary compatibility, you do not have only to monitor the change on the API, but also on the ABI, which I will explain later. And of course, people get very angry if you break something without telling them beforehand. Because when you think about it, well, when I think about it at least, I think versioning is about communication. It's communication between maintainers and users. You want to tell them, all right, this has changed, here is what you have to do, or we changed stuff, here are some nice features, and don't worry, we didn't break anything. But it's all about communication. A word of caution for the rest of this talk. I'm going to be talking about what I think is reasonable use. Because as Titus said yesterday, some people might expect unreasonable things, unreasonable guarantees from your code. They might expect that the line numbers will never change, or that the symbol addresses will remain the same, or that even you can take them, or that, I don't know, the real type of auto types will always be the same, whatever you do behind the scenes, or like the layout of your private members, well, anything. Well, this is not the talk. I'm going to try to focus on the reasonable aspect of what you can define. And if you have other use cases, well, I'd be glad to talk to you about this later on, but this is not the talk because it's a whole different world. All right, let's start with the easiest one, the API, because I think most of you know at least one bit or two about what's an API and the ideas behind contracts. Just to summarize, an API, sorry, is a contract between the user and the maintainer. It is, if you provide me this, if you follow that, if you call this, I will give you this and that in return. And if you don't follow what I asked, well, I can't guarantee anything, I don't know what you will get, and it probably won't work. On the other hand, since you took the guarantee to provide as a maintainer, if people follow the rules, you have to give them something in return, and you have to give them what you agreed upon. It's a mutually binding contract, exactly like you can have in law or in any other domain. We usually divide that in two parts. That's the precondition, which is what people who call you must adhere, must follow. It's what's there on their hands, what they have to respect. And the other hand is what you agree to do if they respect that, the post-conditions. A nice example, for example, of a contract, yeah, sorry, the slide is a bit big, is what you can find on CPP reference. In this case, it's still swap. So when you look at the contract, first you have the name of the contract, the function you must call in order to get something. In that case, it's swap. Then you have where to find it, which header you have to include, and you can already see that technically speaking, C++11 broke binary API compatibility because the header has changed in the release. So technically people will not find what they thought they could find in the same place. Then you have the signature, like what are the types of the arguments, what are the type of the returns, what are the different alternatives. The extra precondition requirements, like for example, the type requirements. For example, in the case of swap, the first type must be move assignable and move constructible. In the second one, it just needs to be swappable. If you don't follow that, swap, well, I can't guarantee what swap will do, and neither does the STL. You're out of luck. And of course, the post condition after that, which is if you followed all the rules I said behind, I will swap both members T1 and T2. Okay, so in C++ terms, what does that mean? I'd like to categorize that in two terms. On the left-hand side, you have what's internal. What I call internal is what the compiler can see, what's part of the language so far. The names, the signatures, the location of your declaration. Any of that, if you break something, the compiler will tell users. It will tell them, all right, the type or mismatch, or I can't find that function, or the name is not what I thought. It's the most easy, it's the most simple part because it's the one that's part of the type system. The second one is what I call external because it's not today part of the language. It's things you expect, it's things you ensure, but it's not things that the compiler can check. It's things that you can only document in some way and that people have to follow nevertheless, because otherwise it won't work. All right, like I said, since not all parts of the API are part of the system, some change are more dangerous than others. If you change the API by something that the compiler can check, well, people will get angry because their code won't compile, but at least they will have some input. They will have something. It won't compile. They have to open your documentation or your header files and say, okay, why did it break? Why can't it find a function? Or why is the type not the same? And chances are they will see that they have to adapt their code because indeed you release a breaking change. On the other hand, if you change the parts that was on the right side, it's quite possible that the compiler will tell them nothing. So if you do not advertise that, people will have some nasty surprises. For the rest of this talk, I will try to categorize the change you made on your code by the type of impact it has on the API. To follow a bit on what I will tell later about Semver, I would say there are three kinds of changes you can make. The most obvious one is the breaking changes. I broke the contract, people have to change their code. If they don't, things will go bad. If you're lucky, it won't compile. If you're unlucky, it will be even more terrible than that. Second one is the non-breaking impact. It's you added some stuff, you offer new opportunities, but for existing users, it should be transparent. They won't have to do anything to adapt. And of course, there's the last kind of change, is that you change something to your code, but the API has not been impacted at all. Let's see that in detail. Easiest one first. No change. Changes with no impact. Well, that's easy. If you did not change any contract, well, you did not change the API. So basically, if you fix a bug, if you do some performance tuning, or if you refactor your code internally because you changed the implementation, but all the observable and guaranteed behavior is the same, well, that's a no impact change. So basically, what does that mean in C++ terms? That means no names or signature have changed. All the defined behavior is the same, like I said. And that, it's important, it includes specific guarantees. Like, for example, if you went the extra mile and said, all right, my function is guaranteed to work in a linear time, or if you say, all right, my function will not invalidate any iterator, you cannot change that. It's a breaking change. So if you did not change anything in the API, but still have like a worse algorithm, for example, it's not no change. There is an impact right here. So what's the non-breaking change? Well, anything you add that does not touch what existed before. So like new functions, new namespace, new variable, new struct member, new type, whatever. That does not change the API. Everything that was previously there is still there. I put a star on new overload because, like we said prior, if some people are trying to like get the address of your functions, if you add an overload, they might have some surprise. But other than this case, a new overload is supposed to be safe. You can also relax an existing contract. Basically, what I mean by that is that you change a contract, but only for the better or for new options. Like, for example, if your function took 2 arguments in the past and you add a third one, but that the default value of the third one gets the same behavior as before, you did not break the API. People can still call your code as they did before and expect the same results. If you add a new struct members, like I said, it has no impact on the API. All the other ones are still be found in the struct. No names have changed. If you relax the precondition, if you accept more values than before, it's OK. For example, if your function in the past said, no, I want only positive integers, and now you can give me any integers, well, you just define a previously undefined behavior. That's totally acceptable. You can also narrow a postcondition. Like if you said on the past, I will only return a number between 1 and 20, and now I will only return a number between 1 and 10. 1 and 10 is between 1 and 20, so it's still OK. You did not break your promises. Of course, you can also narrow the guarantees. If, for example, in the past, you guaranteed people that your algorithm will run in n log n, and now it just runs in n, that's just better. So people will be on board with that. It's not a breaking change to me, and I don't think it's to you. And of course, like we said before, basically defining any kind of undefined behavior is not a breaking change. People should not rely on undefined behavior. I think it has been told many times, even in this same room. I don't need to insist on that. So what's the breaking change? Well, basically everything else. For example, if you change the signature, like you change the argument types, or you change the return types, or you change the order, well, it won't work. Some exception, or maybe some exception, if you have like a new, if you use a compatible type with an implicit conversion, it might be OK. But beware, because there are lots of conversion rules, and if you had like few overloads already, and you change one of them, make sure that all the previous ones still match the same thing. For example, if you mix up strings, pointers, booleans, and integers, sometimes if you change one of them, the overload will not select what you think for every type that they did in the past, and people will get nasty surprises. I did have some issues when you pass a bool and the first conversion selected is like, oh, okay, you said false, that means you mean null, right? So that means it's a string. No. And yeah, well, I see some people laughing. I guess that I wasn't the only one to which that happened. Of course, renaming, if you rename something, it won't compile, so clearly breaking change. And the last one is maybe less obvious, but still, if you move something from one header to another. If people have to include something else to find your code, well, obviously you broke the API because it won't compile. If you narrow a contract, if you add more restriction than before, of course, it's a breaking change. Reverse from what I said before, if you accepted all integers and now you only accept positive integers, a lot of people, like maybe half of them, will be unhappy because they used to be able to do that and now they can't. On the other hand, of course, if you relax the post condition, it's the same issue. If in the past you guaranteed people that you did not invalidate any iterator and now you do, you will have some very angry people calling you. That's evil. Basically, that's evil. Because what happens if you narrow a contract? Well, basically, you changed your API, but if that's the only change you do, the compiler will still compile fine. It will be completely unobservable for people until they run your code, if you're lucky in test, if you're unlucky in production, and they will get very, very unhappy. No, seriously, don't do that. Do not narrow a contract if that's the only thing you change. One more example, just to be sure that I hammer the point. Let's see some change. So, in the past, I had a function that was supposed to sort a vector of ints. I documented the contracts on top. I'm a pretty nice guy. I told them, all right, I sort a vector of integers, and I guarantee you that I will do it in n log n. And implementation details is std sort. Great. Now I change the API. I say, OK, I still sort your vectors of integers, but I change the pass condition. Now the complexity is an, sorry, what's the? Factorial. Yeah, factorial n. Thanks. Because inside it, I use bugger sort. Are you familiar with bugger sort? Yeah. Yeah, funny algorithm. For your culture is basically you try to see if it's sorted, and if it's not, you shuffle everything and you try again, seeing if that time it's okay. That's an optimized version of it, by the way, because if it's already sorted, it will not block. So that's the optimized bugger sort, technically speaking. Yeah, but you see the point. You've been a nice guy, you know? You changed the contract and you documented it. That's fine. You say, okay, hey, I did not take you by surprise. The contract is documented. I changed the complexity, all right, but I told you. Why are you unhappy? Well, you broke the API and the code still compiled. Even the best intentioned people in the world will not look always at your changelog if you say you broke the API. Most of the time, they will notice that you broke the API because their code don't compile. So if you do a nasty change like this, and people don't get a compiler, some of them at least will push that into production, expecting that, the change did not impact me. And sometime later, you will get some very angry calls. If not a lawyer. So again, if you have to break the API, break it. Like don't break it in half. Like don't do it half-assed. Just go for it. Break the types, break the names, break everything you can, so that the compiler will stop people, and they have to take some time to figure out what you change exactly. Don't just change something that the compiler does not see. It's just too dangerous. Okay, let's talk about changes in ABI now. compatibility with binaries thing. Okay, so who here knows about ABI? I'll see. About half the people? Right, so I think it's a nice time that I take some time to refresh your memory. So ABI is Application Binary Interface. It's the way your binaries talk to each other. It's really how programs talk to each other in your computer. It's what defines how it works. And the funny thing is, it's not part of the standard. I put a little star there because there is a very, very, very small specific part that's defined in the standard, but most of it is not defined by the C++ standard at all. It depends on your platform, on your compiler, on a lot of things, but not on the standard, which, of course, makes it tricky. Again, I'd like to split that into two parts. The part on the left is what I call the infrastructure part. It's all the rules from the ABI that comes from your choice of platform, CPU, OS, compiler, that kind of stuff. And that's the part of which I won't talk, or probably not talk much. Because it's the part that you, developers, API maintainers, do not have to care about. It's basically the choices of the people who use your code. It's up to them to make sure that if two binaries are to talk to each other, they have to use the same infrastructure. That's not your problem. It's a problem, but it's not your problem. And since I don't have unlimited time, I will focus on the second part, which is what derives from your code. What can you change in your code that might have impacts on the ABI? And mostly it's about changing symbol names, it's about representation of binary types, and it's about vtable. First one is maybe the most known one. It's mangling. Mangling is the idea that the linker that you use for C++ is still very tied to the C platform. So that means that it can only understand names that have underscores, letters, and numbers. That's about it. But the problem is in C++, a name isn't just a name. It's the name plus the type of all arguments plus the namespace. And as you can see, things like colons or stars or whatever you can find in a signature, that doesn't fit in that standard. So in C++, you have what we call mangling, which is basically you give me the name, you give me the signature, I mix and match that, and in the end I output some ID that's compatible with the C names, so that your linker, your platform is able to work with that. The algorithm, again, is not defined in the standard. It's usually defined by the compiler. Most compilers try to be nice and have the same on the same platform, but that's not even a guarantee. So, for example, here I have two overloads for the same function foo. First one takes int, second one takes double. And as you can see, the exact name that comes out is a bit different. So what's the first thing we can deduce from that is that if I change the type, I change the signature, I change that nice I and D at the end of the function, so I changed a symbol name. And as we might all, I think, have run into at least once in your career, if you change the name in a library and you run a binary, you'll get a nice pop-up on Windows and a nice error message on Unix that tells you I cannot find that symbol. So basically, even if you do not rename a function, if you just change the argument type, you change that magical ID, and it's not binary compatible anymore. And what's funny in there is that you don't have to care about your public function. You do not only have to care about your API functions. Because the natural thing would be to think about, okay, I just have to wonder about, did I change the API? But that's not only that. That also could be implementation details. For example, if I do some inlining, because it's what the call kit do, I have a function foo, which is part of my API, and then inside, as an implementation detail, it calls a function in the details namespace, which is usually reserved by the maintainer, and is not a public API. So technically speaking, if I do that change from left to right, I did not break the API. Function foo is still there, it still compiles fine, define behavior is still the same. But there's a symbol here that's not the same. Bar in the past took no arguments, now it takes one. The magic name in the end is not the same. So what happens? Well, I get a link error, or I get a loader error, and to the external view, the API does not change. But I change the symbol anyway. So you do not have only to care about API methods, API symbols. You have to care about any symbol that's exported in your system. And I think that's where, where is James? There he is. I think that's where Windows got it right. Because in DLL, as is shown yesterday, it's private by default. You have to explicitly state that symbol will be exported. So it's quite easy to look at your DLL or to look at your export file or just run a grep on your configuration to know which symbols you have to care about, especially if you have to export them manually, because then you know that you have broken the ABI because you renamed the symbol. On Unix, on the other hand, the default is that anything that's not static or inside an anonymous namespace will be a public symbol. It's much harder to determine if you change something that will be visible to the outside world and then break their code. Usually, what I would recommend you, especially if you want portable code, is to use the export macros that CMake can generate for you, that you can do by hand, that expands to DLL export import on Windows and to nothing on Unix, because you can easily grab that and say, okay, in the diff, did any of those lines change? Because if it did, you probably broke the ABI, even if the API is still the same. Got it? Great. Now let's talk about the vtable. The vtable is how your compiler will store the layouts of the function pointers to your classes. Because as we all know, when you have a virtual method, it's at runtime that the code will try to think which method to call in practice. And that's usually done through a function pointer table. That, again, is not defined in the standard. That's up to your compiler. And usually, you can expect it to be the same from one compilation to another, as long as you don't change anything. But since it's just a table of pointers, offsets that the compiler, that the code will blindly jump to, if you add a method in there, you will probably change some offset somewhere, and it will not go well. Especially if two sides of an API on two libraries disagree on what the vtable layout is. Like if the first library thinks there are four methods, the second one thinks there are 5, and that the particular one you want to call is the third one, and they don't agree on which one it is, you will have some nasty surprises. So basically, if you reorder the virtual methods, or if you add one, you will probably change the size or an offset, and things will go badly. And since we're on binary representation, the last one is maybe the most known one because we've seen it in C. It's the layout of the structures. Because, your compiler does not, the compiler does, but your machine does not see your nice struct layouts. Your machine just sees offsets and size, basically, and some very basic assembly types. So if the size of a structure change, if the size of a member change, or if the offset of a member change, you will have some issues. And the funny thing is, it depends on your platform. It can change from one way to completely another depending on the rules of your platform. for example, between ARM and x86, or between x86 and Spark, you don't have the same rules. So in one case, it might even seems to work. And then you push the same change with the same release binary on another platform, and it doesn't go as well. Basically, the idea is that you take your nice little structure in C++, and then your compiler translates that into a binary layout. For example, my int, that's on my machine, so x86, 64 bits. On my machine, I have first 4-byte integers, then I have a bool, a pointer to a char, and then a double. Okay, this is what it looks like on my machine. The first one, the compiler puts it just at the start of my structure because it can. Then I have a Boolean just after that. Then I have a pointer. And the ABI on the machine says that every pointer should be a line on its size, which means it should start on an offset that's a multiple of its own size. So for example here, the next available bit would be address 5, but it's not a multiple of 8, as far as I know. So the compiler will add some padding to be able to follow the rules. So of course, if I had a member at the end, well, the size change. And if I added a member between M3 and M4, again, because of the alignment rules, it will push everything. So usually, if you change anything in a struct, like if you change sizes, if you change order, or if you change offsets, it will not be binary compatible. And even more than that, if you change a member visibility, it will maybe not be compatible. Because that's where I come back to the only parts of the standard that talks about the ABI. There are two ways the compiler can translate your nice structure layout into binary. There is the C compatible one, and there is the, well, let's say the new C++ one. And they do not have the same rules and the same guarantees. The C one says everything should be in the same order, aligned with whatever platform rules you have. The C++ says, and it only activates if you have at least 2 members that do not have the same visibility, for example, public and private. Then the compiler says, okay, you're not trying to do C compatibility, I have more leverage to reorder the members if I want. So it's even more hard for you to know if the ABI will break or not. The easy rule is just to say, okay, I change anything in a structure, any type, any size, any ordering, it's not binary compatible anymore. Of course, here I'm talking about the types you exchange through your API, the public types. Any type that both sides of an API have to see. Because if it's only internal in your code, well, you can change it as much as you want. Your binary is just one unit. He will always agree with himself, hopefully. But at least as you are 2 people talking about one kind of structure, a public structure, they have to agree on the layout. If they don't, bad things will happen. If you're lucky, it will fail very early. If you're unlucky, it will, like, I don't know, confuse the pay and get members of your financial structure, and your clients will get money every time they buy something instead of paying you. Okay, so how do we put all that together and try to do some versioning? I think there was a nice introduction to Semver yesterday, but still, is all of you familiar with Semver here? Or do I need to? Could you raise your hand if you know Semver? Still, okay. Maybe half the people don't know about Semver, so I think a quick recap could be interesting. Basically, it's a versioning scheme that was created, I think, like 6 or 7 years ago by somebody at GitHub. And it's a formal convention to express the impacts of changes in an API. It's 3 numbers, X, Y, Z. X is major, Y is minor, and Z is patch. Basically what it says is that a major change is anything that has impact. Any breaking change should be a major release. Any minor change, any minor release is for changes that don't break anything, but still add new behavior. So they are changes, but not impacting one. And the last one is the patch, which is not anything in the API is the same. You are safe to upgrade or even downgrade if you think you have to do that. It should be okay. So how do we handle that? Well, my suggestion, until we might move to a new world of living ahead, until that, if that ever happens, is to follow some kind of convention. And, well, until then, I didn't find a better one. Maybe there are, maybe there aren't, but at least we have something, we can agree on something. Maintain a change log. It's not enough to tell people, all right, the version has changed. Because if you just tell people a version has changed, well, usually it means, okay, brace yourself, you might have issues. I don't think it's enough. No, it should be, okay, I changed something, please go look at the change log. See if that's impacting to you or not and adapt your code. Of course, since we said that half the stuff in the API was not part of the type system, you have to document that. Because it's agreements, and if you have to agree on something, it must be written somewhere. There must be one source of truth that people can use to talk about something. So please document. Anything you want. It could be like a Markdown file in your project. It could be a wiki. It could be Doxygen. It could be just comments. Whatever you want, but document them. And again, do not do any kind of invisible breaking change. If you change something in the API, go for something that the compiler will see. Go for something that will trigger compilation error. Do not do the pogo sort thing. I know that's a caricature, but something much more sinister can happen and have happened a million times in the past because people change the API and they only change the part that was not seen by the type system. How do you include ABI? Well, first option is don't. I mean, I'm totally on board with what was shown recently. If you can avoid it, it's much easier. As you have seen, as many people have told before, ABI is complex. It's lots of rules. They depend on the platform. Even in some case, it might work on your machine, but not on the server machine because it's not the same CPU or the same OS or whatever. It's dangerous. It's not easy to handle. And if you are header only, it's not even a choice. You do not need to do that. So easiest change, if you can ask your clients, always recompile, do that. It's much easier. You will sleep better. But sometimes you can't, like I said. Sometimes you maintain the low-level library, and your clients will call you and say, all right, there is a security issue in your binary. I need a binary fix by tomorrow. And I need a binary fix that will not require me to rebuild everything I based on your product. And if you have that, you have to find a way. And that's ABI, binary compatibility. So my suggestion in that case, if you want to take binary compatibility into account when you publish your library, is that you adapt Semver to talk about that, because Semver only cares about API, because ABI is, well, a C++ concern. So basically, what I would suggest is that if you break the API or the ABI, you say it's a major change. People cannot expect to swap the binary. People cannot expect their code to compile. They have to do something. If you only made backward compatible change, it's a minor release. You just change something, but people can safely binary upgrade. They can simply recompile without changing their code. It will work. And of course, there's the patch, which is I did not change anything that's a part of the contract. I just fixed security issues. I just improved the performance. I just done internal refactoring. No symbol has changed. Nothing has changed in the ABI or the API. It's just a patch. Go for it. It's safe. What about dependencies? That's the part when the binary compatibility gets tricky. Is that, well, if you change the major revision of a dependency, well, most of the time, that means that your API changed. Because people who built you will have to rebuild again and possibly adapt the code. Maybe the library you expose in your thank you. Maybe the library you use as a public type has changed its API too, so people will have to adapt. I would say it would break your API, and it can also break your ABI, of course. If one of your dependency has a new ABI, well, your clients will probably also know about it because they will get some errors. And of course, if you change the major revision of a private dependency, it's also mostly probably a breaking change for you in your ABI. Because your binary, if they just swap your binary and nothing else in production, it won't work because the dependency expected are not the same. It's a tough subject. I wish I had more time to talk about it. But like most people say, usually that comes to a package manager or to some heavier artillery. Can I do more than that? Can I do more than just advertise people that I change something? Because changelog is good, documentation is good, bumping a version to signal people to read the documentation is good. Can you do more? Yeah, of course. You can go the extra mile. You can provide people with migration script, like a Clang script, for example, or anything else, even maybe a SED. I don't think a SED will be enough, but any kind of script that maybe people can use to just upgrade, that would be nice. Because the problem is if you break the API too often, well, people, us developers, we are lazy. We don't like to do work we can avoid. So we just don't upgrade if we can avoid it. So if you provide people with scripts that can help them switch painlessly to the new version, they will thank you. And the more they do, the less you will get support requests for older release. In the future, I don't have much time left, so I'll go right over it. Basically, two things might impact this talk. That might be the contracts, because we may finally have something to put at least more parts of the left-hand external parts of the API into the compiler. We may have some options to tell users, okay, that part changed. And maybe you will not have to break anything if you change the contract. You may be able to rely on the compiler to tell users that now they cannot expect the same thing. And of course, if modules come, and people may start distributing not headers, but only the binary modules plus maybe the library. And that might change the way you distribute software or the way you document stuff. For example, if you have only modules and no more headers, maybe they will never have an option to see code inside the headers, so no documentation, nothing. They will have to find another source to detect that something has changed. Okay, now it's time to wake up and see if you followed everything. Because as Björn told us, if you tell students that there will be a test, they will only study for the test. So I didn't tell you beforehand. Okay, let's go. Basically, every time I have a change, you tell me, is that a breaking change? Did I break the API? Did I break the ABI? Did I change any of them? Did I change nothing? All right, first one. What did I break? Did I break the API? Yes. Yeah, basically I did, yeah. Did I break the ABI? Also, yeah, great. I broke everything. Well, that happens. Yeah, a new member, you broke everything. Okay, int to long. Did I break the API? Maybe. Well, I would say no, because technically I'm just accepting more values, but it's backward compatible. I changed the API, but I don't think I broke it. But I broke the ABI, because it's not the same binary signature for my method. Okay, I have a nice structure, and I swap two members. Did the API change? Yes, no? No, the answer is no. No, it's just names, and the compiler does not care about the order of names. Fortunately for us, C++ is not a language where the offsets have an impact on the compiler. But I changed the order, so the ABI is completely broken. Okay, now I reordered two methods. Did I break something? James? Yeah.
So this actually is a breaking API change because, for example, you can aggregate initialize a struct A instance, and so now you've broken all those aggregate initializers.
Ah, yeah. Nice one. You said no, Ekel. Maybe that was from my previous talk. I didn't read the fine print. I didn't read the contract. My fault. Okay. And this one, yeah, didn't change anything. I didn't break anything. I just reordered two members. No problem.
Excuse me, can I go back one?
Yeah.
What if you take, for example, you store the address of this member function for something else?
That's not an issue. They are not stored inside the structure. They are just names. That has no impact. No, because member function, they don't have an address that depends on your object. It's just a function with the first argument being this. It's not the v table.
We'll look it up by name, right?
Yeah.
The symbol didn't change.
Yeah.
The can still
Yeah.
look it up by name.
Okay, this one is my favorite. Before that, my function returned the sum, and now it returns the max. Yeah, exactly, evil. It's an invisible breaking API change. What are you trying to achieve here? Are you just trolling me? That doesn't troll me, that makes me mad. Somebody will pay for this. Okay, this one is the one you referred to. In this case, I changed the vtable, so I broke the ABI. Okay, this one is quite tricky, and it only works on my machine, so the answer will depend on your machine. And the answer is, on my machine, it works. Because, if I had 2 bytes after a Boolean, the alignment rules on x86, 64 bits, will say that the layout of the structure is still the same for all the previous members. So maybe I did not change the ABI, but you notice the star? I would not rely on it. I think there's a talk maybe tomorrow or today about what you can do to avoid ABI change in that kind of thing. That's something that might save you, but most of the time, it will just come and bite you. So you did not hear that from me.
That has the same problem that he mentioned before.
Yeah, also that. Okay. Now, this one. Breaking? What did I break? Did I break anything? Yeah, I broke the ABI. The API is still, well, backward compatible because I have a default argument, but the ABI is not the same. One more argument, not the same name. Well, easy. I renamed the function. Well, obviously, nothing will work. I don't know what people would expect. Okay. Did I break something? Yeah, exactly. I broke the API. The name is not the same, but the offsets is the same, and since the ABI don't see names, they see offsets and sizes, it's fine. Okay, this one may be a bit harder to read, but Basically, it's just pretty similar to the one I shown before. The API is the same, but I renamed an internal implementation function, which has to be exported, and so I broke the ABI again. Okay, so I've been told that it's nice to end the talk with a nice quote, so you might have heard some variation of that, is that no system became successful by breaking backward compatibility. To which I will add my personal quote, especially if you did not want people beforehand. Remember, versioning is about communication between maintainer and users, so talk to them. Tell them when you break their stuff. If you have to break something, break it hard. Do not break it silently. Thank you. And really talk to them. Tell them when you change something. Thank you. We have about 5 or maybe more minutes for questions. So if you want, you have 2 mics. Sorry, is this thing on? Okay, I just repeat.
2 comments.
Don't have to.
Okay.
Wait.
GCC also has a way to specify which symbols you want to export and which you don't. It's a pragma visibility something.
I'm sorry, I didn't get that.
GCC has a way to specify which symbols you want to export from library.
Yeah.
Yes.
Yeah. There are 2 ways you can do that. On Windows, James showed us today that there is the export list. On Windows, on Unix, there is the F visibility setting on the compiler that can tell that you should change the behavior to exports. It's quite painful to use by hand, but I think you can use CMake or maybe a verbal system to do that for you and change the default. But the default is that everything is visible, and you have to use the dash visibility toggle to change that.
Can you go back to that slide where you map same word to C++ changes? About that.
You mean the one with the mangling?
No. Where you say, change this part of same word if you break this and.
Okay. Oh, tell me. The one about Semver, right?
Yeah.
This one?
Yeah.
Okay.
So to me, as a user of your library, it seems like the last 2 are indistinguishable. You didn't break anything. In fact, it's not even clear why you would. You said there's no change. Why would you increment a patch?
Well, technically, like I said, it's because you have to do some internal refactoring, so there's no impact on users, but you might want to push that code anyway, because we're all maintainers. Sometimes there are old code we want to refactor, change. That has no impact on anybody.
But it's the same as the second one, non-breaking change, right?
No, because you can go back if you want, technically speaking. I don't recommend that, but sometimes people, they want to downgrade. And with a patch revision, it's safe to downgrade, technically speaking. Usually you don't do that, but sometimes you push a refactoring and it ends up with bugs. And people might want to know if it's safe to go back 1 revision if they have to for some reason. Especially, which is one of the problems with versioning at scale, is that you have two restrictions from diamonds somewhere that want 2 different revisions. You might have to settle for the oldest one for some reason, and with that you can tell, okay, it's possible. It's not ideal, I won't say that. But sometimes you want to say, okay, I can downgrade because there is a critical bug in the latest that has not been fixed yet. It's becoming more and more frequent today because we have faster release cycles, but it can still happen.
Thanks.
Second comment, sometimes when you decrease time of functions, it's also breaking change. For example, if a function compares 2 strings and it's guaranteed to run till the theta n, And if you optimize it to return early, if it finds mismatch, it can be breaking change for security, because hackers can compare time.
Well, I guess that depends. Did you guarantee in the past that your function will take at least some time? If you did, well, yeah, you broke the API. But if you did not take any guarantee, well, people base their stuff on implementation details. And as we all have been told countless times, yeah, well, you shouldn't do that. Thank you very much.